WAEC 2024 Objective Question 21. Now we are given a diagram, and in this diagram, in the question, we have that MN is parallel to KL. So we have ML parallel to KL. Moving on, we have that ML and KN intersect at X. MN is equals to 12 centimeters, MX is equals to 10 centimeters, KL is equals to 9 centimeters, and we're given the question that the area of MXN, that's the triangle MXN, is 16 centimeters squared. And likewise, the area in triangle LXK, we should evaluate that. So to simplify this now, let's bring out the two triangles together because this is a question on similar triangles. So let's draw out the two triangles. We have MXN, and similarly we have triangle KLX. So this is 9 centimeters. We have 10 centimeters and 12 centimeters. The area of this triangle is equals to 16 centimeters squared, and the formula for area is half base times height. So let's call it B1 and B1. So the base in this triangle is 12 centimeters, so we have B1 is equals to 12 centimeters, and the height is unknown, H1 unknown. So we can say this is a pictorial representation of H1. If we move to the second triangle, we know that the area, that's what we are looking for. The base in this triangle, or before then, what is the formula for the area here? Half base times height, but this time we'll be using 2. So the base here, B2, is 9 centimeters. Similarly, H2 is unknown. Let's depict diagram with A2. So we have H2 in this case. So all we just have to do now to evaluate this area is to evaluate what is H2. Now if you look closely at this diagram, are these two angles, these two triangles, are they similar in nature? I will say yes, because if we have an angle theta here, provided that these two sides MN and KL, they are parallel to each other, then this angle is also theta according to alternate angles. Okay, so if you have theta here, we will also have theta here. So this shows that we are dealing with similar triangles. So let's proceed on now. Let's begin with the evaluation of B1. So let's apply this formula. The formula says area is equals to half HB1 multiplied by H1. Therefore, 16 is equals to half multiplied by 12 multiplied by H1. So 16 is equals to 6H1, then H1 is equals to 16 over 6, which is 8 over 3, 2.6667 centimeters. So that is an expression for H1. We can depict it in this diagram now, that H1 is equals to 2.6667 centimeters. Now once we evaluate H1, how do we evaluate H2 without going through any trigonometric functions or any trigonometric identities? All we just have to do is to apply our similar triangle. So to do that, we will duplicate this triangle. Let's duplicate this triangle for ease and bring it downwards. In the same vein, we will duplicate this triangle and bring it downwards. Okay, now once we have duplicated this triangle, we want to evaluate H2, and to make it more reasonable, let's turn this triangle upside down and let's redraw, and redrawing it with a black ink. We will have X, K, and L. The base is 9 centimeters, and the height that we're looking for is H2, and there is an angle theta at this location. So with that, we can now apply similar triangles, and the similar triangles will have that h1 divided by 12, that's the height, divided by the base, will be equals to h2 divided by the base. For this triangle, h1 is the height, the base is 12, and for this triangle, h2 is the height and the base is 9 divided by the base. So we have a value for h1 already. So h1 is 2.6667 divided by 12, and h2 is what we're looking for divided by 9. So making h2 solve the formula, this will result into 2.667 multiplied by 9 divided by 12. Simplifying this, we will have 2.00 centimeters. Now that we have h2 to be 2.00 centimeters, we recall that we are looking for the area of KXL, and the area of KXL is half base half B2 times h2. So let's duplicate this and move downwards. So we are looking for the area of this triangle, and we have simplified that h2 is equals to 2 centimeters. So with that, we can evaluate the area of the triangle. Let's use the red ink now to be half the base is 9 and the height is 2, and this will simply result into 9 centimeters squared, and this is option B. So let's take a quick recap to ensure that we have understanding of what we just did. Now if you take a close look at what we did now, so we'll see that we first evaluated h1 by using half base times half b1 multiplied by h1. So we evaluated h1, and we understand that the same formula applies for this. All we just have to do is to evaluate h2. Now we apply similar triangles because they have the same angle theta. So angle theta, and now we use the height divided by the base, that's h1 divided by 12, and the height divided by the base, and that is h2 divided by 9. So we have evaluated h1 to be 2.6667, and then we can evaluate h2 to be equals to 2.6667 multiplied by 9, and we'll have h2 to be 2.00 centimeters. And since we know the formula of the formula of the area we're looking for, that's half base half b2 multiplied by h2, and we'll have the result to be 9 centimeters squared, which is equivalent to option B. Now moving on to question number 22 of WAEC 2024, the objective part. We have a question here that involves trigonometric identities or trigonometric ratios. The question says a ladder 15 meter long leans against a vertical pole and makes an angle of 72 degrees with the horizontal. Calculate, correct to one decimal place, the distance between the foot of the ladder and the pole. Now let's say this is the vertical pole. Let's call this the vertical pole, and then we have a ladder that leans against the vertical pole. The ladder is 15 meter long, so let's call this the ladder. This is the ladder. Just trying to make a depiction. Someone is trying to climb up the ladder accordingly. So this is the ladder. Leaning against the vertical pole, making an angle of 72 degrees. So we have an angle of 72 degrees with the horizontal. We are asked to calculate to one decimal point the distance between the foot of the ladder. We can say this is the foot of the ladder and the pole. So we are looking for the distance between here and here. So let's call this x. So this question is very simple, and we are going to treat it as a right angle triangle. So let's simplify it further and make the triangle more simplified. So we have a right angle triangle with the adjacent of x, and this is 72 degrees. Now, one important thing, the ladder is of 15 meter long. You can see it in the first line of the question, 15 meters long. So this is 15 meters and we are looking for x. So now let's close up on that and let's focus on what we have here. If you recall, in trig ratios, in our trig lessons, we did on SOHCAHTOA, that sine, okay, zoom in on this, sine is opposite over hypotenuse, cos is adjacent, okay, over hypotenuse, and tan is opposite divided by adjacent. So in view of that, what is our opposite in this triangle, what is our adjacent, and what is our hypotenuse? The side facing the triangle, or the side facing the angle, is known as the opposite. So this is the opposite. The longest side is the hypotenuse and the last side will be the adjacent. So we are looking for the adjacent. X is the adjacent, okay, or adjacent is equals to x. We have the hypotenuse to be 15 centimeters and we have the angle theta to be 72 degrees. So the question is, what relates adjacent with hypotenuse? And we can see that what relates adjacent with hypotenuse is cosine. So we can say that cos theta is adjacent divided by hypotenuse. So making our substitution, then cos 72 degrees, because theta is 72 degrees, is equals to the adjacent x that we're looking for divided by the hypotenuse, 15. Therefore, what we are going to do now is to make our angle. So if x, making x with the formula, so this is x is equals to 15 multiplied by cos 72 degrees. Cos 72 degrees, according to our calculator, is going to give us 0.3090. Then if we multiply this by 15, we'll have the results to be 4.635 meters. Now the question says we should correct according to one decimal place. So if you correct this to one decimal place, we'll have 4.6 meters to one decimal place. So remember, all we did was SOHCAHTOA. Sine is equals to opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now we have WAEC 2024 objective question 23, and we are given this diagram, and the question says, in the diagram, O is the center of the circle, okay, and OA is equals to 25 centimeters, AB is equals to 40 centimeters, and we are asked to find length OH. Let's call this length X. Now let's analyze this diagram now. If we look at length, line OH is a perpendicular bisector that divides this angle equally. So if we divide this angle equally, so this will be theta over 2, assuming theta, and this will be theta over 2. And just as it divides that angle equally, it will divide line AB equally. So it's going to divide line length 40 centimeter equally. So this length becomes 20 centimeters and this also becomes 20 centimeters. So in view of that, we can bring out just one triangle. So let's bring out this triangle, the right handed side. Remember, it's a right angle triangle. So bringing out that triangle, we have something like this: O, H, and B, right angled, X, and 20 centimeters. Remember, the length here is the same thing as the length here, so this is 25 centimeters, we'll also have 25 centimeters. 25 centimeters is the radius. So how then can we look for x in this situation now? Now, if you recall closely that in right angle triangle we have something called Pythagoras theorem. That Pythagoras theorem says that the hypotenuse squared is equals to the opposite squared plus the adjacent squared. So this we can call the hypotenuse, this we can call the opposite, and this we can call the adjacent. So with that we can find the value of x. So let's make our substitution. Hypotenuse is equals to 25. The opposite is equals to x. So we have x squared, and the adjacent is equals to 20. So we have 20 squared. So making x squared subject to formula. So we have x squared is equals to 25 squared minus 20 squared. So with this, 25 squared is 625. 20 squared is simply 400. So we have x squared to be equals to 225. So taking the square root of 225, we will have the value of x, and we'll have that x is equals to 15 centimeters. So the length of x is simply OH, which is what we have in the question. That OH is equals to 15 centimeters, which is equivalent to option A. Let's move further to WAEC 2024 objective question 24. We are given a question on navigation and bearing. And before we proceed, let's establish the facts on navigation and bearing. So we have north, south, east, and west. Now for navigation and bearing, the angles start reading from the north 0 degrees, east 90 degrees, south 180 degrees, and the west 270 degrees back to the north at 360 degrees. So in view of this, let's focus on the question at hand. The question says, given that P is 5 meters on a bearing of 330 degrees from Q. So that means it is from Q we are going to measure 330 degrees. So let's have a position of Q here. And from Q we have the north also, south, east, and west. Of course, we know the angles 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees, and this is point Q. Now, Q at point Q to P is 330 degrees. So that means we are going to start our reading from the north, and the 330 degrees will be around this point. So this is 330 degrees, and thereafter at this line now, at this angle, we are going to move towards P. So from here there will be a new point called P. The question now says, how far south of P is Q? So we are looking for how far south of P is Q. Remember, on P we also have our north, south, east, and west. So how far south means what is the distance in the south direction up to point Q. So that means we're looking for this distance x. So with this, we'll just have to complete this diagram, and this will be at right angle degrees. Now with respect to this, we just have to complete the diagrams. Okay, now let's consider the angle now. If this point here is 270 degrees, and the total angle, okay, and the total angle is 330 degrees, then this angle here will be 330 degrees minus 270 degrees, and this would give us 60 degrees. Now once that's done, then we understand also that this position would be 30 degrees, because 60 plus 30 degrees will give us 90 degrees, which is the dimension or the angle in the quadrant. So in view of that, we are looking for the value of x. Now, if we go back to the question, it says that given that P is 25 meters on a bearing of, so that means the distance between P and Q is 25 meters. Now, let us now draw the diagram out. We have P, we have Q, we have a length of 25 meters, is at right angled, and we have angle 60 degrees, and we are looking for X. Now, this is where trigonometric ratio comes to play. In trigonometric ratios, we will have SOHCAHTOA, where sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So the side facing the angle, we'll call it the opposite. So this we'll call the opposite, this will be the hypotenuse, and this is the adjacent. So the question is, what is the relation between opposite and hypotenuse? So opposite and hypotenuse is related by sine. So with this, we are saying that sine 60 degrees is equals to the opposite. The opposite is X divided by the hypotenuse, which is 25. So in view of this, we can now evaluate our X. So X will be 25 multiplied by sine 60 degrees. Now if we plug sine 60 degrees into our calculator, we will have it to give us 0.8660. So this will be 25 multiplied by 0.8660. Sum will give you as with 3 over 2, and we will have this to give us 21.65 meters. Approximating to one decimal place, we'll have this to give us 21.7 meters, and which is equivalent to option B. Now you can see we started from the old diagram, we reduced it to a right angle triangle, and we evaluated the value of X using trigonometric ratios. WAEC 2024 objective question 25. The question says a car valued at $600,000 depreciates at 10% each year, emphasis on each. What is the value of the car at the end of 2 years? So at initial value, let's call it V, the value is $600,000 rather. So now it is depreciating every year by 10%. So we are looking for the value after the first year, let's call it V1, and also the value after the second year, V2. And now let's begin. So to get the value of the first year, we'll understand that it is depreciated by 10% of the value of the initial value, and at the second year will be the 10% depreciation of the value after the first year. So at the first year, let's call it V1. The value V1 will be equals to the initial value minus the 10% depreciation of the initial value. I think we did something related to this in question number 9, where we talked about population increase, but then that increase shows that it was an increase, positive increase, so that we will use positive. But now we are dealing with depreciation, or we are dealing with negative. So therefore, applying this now, the V is 600,000, the 10% increase of V, 600,000. So simplifying further, this will give us 600,000 minus $60,000, and this would give us $540,000. So we have V1. Now to get the value at V2, that means at the second year, at the end of the second year, we are going to depreciate the value at the first year by 10%. So at the end of the second year, V2 is equals to V1 minus 10% decrease of V1. So applying this now, we'll have 540,000 minus a 10% decrease of $540,000. So simplifying further, this will result into 540,000 minus $54,000, and this will result into $486,000, which is what we are looking for. Now let's take a quick recap. The car initial value is 600,000. It is depreciated 10% every year. So at the end of the first year, we'll have it depreciated to this value 540. At the end of the second year, depreciated to 486, which is equivalent to option B. Now, WAEC 2024 objective question 26. This is a question on the total surface area of a cuboid, where we have the length and breadth of a cuboid are 15 centimeters and 8 centimeters respectively. If the volume is 1,560 centimeters cube, find the total surface area. So let us draw the diagram representing the cuboid. So we have the length, moving on with the breadth. So we complete the diagram with this. Apologies, it's not looking quite like it, but we'll manage it. So we have the length, the breadth, and then the height. Now we are given that the length is 15 centimeters, the breadth is 8 centimeters, the height is unknown. But then the volume of the cuboid is 1560 centimeter cube, and we are asked to find the total surface area. Now, how do we solve this? What is the formula for the volume of a cuboid? The formula for the volume is length times breadth times height. Similarly, the formula for the total surface area of a cuboid is given as 2 into length times breadth plus length times height plus breadth times height. So in view of that, we can evaluate our height from the volume, and once we have the height, we will evaluate the total surface area. So let's move on. The volume here is 1560, the length is 15 centimeters, the height, the breadth is 8 centimeters, and we are looking for the height. So therefore we are saying the height is 1560 divided by 15 multiplied by 8. So this means the height using our calculator is equal to 13 centimeters. Now that we have the length to be 15 centimeters, we have the breadth to be 8 centimeters and the height to be 13 centimeters. So therefore we can easily evaluate the total surface area. So therefore we are saying the total surface area of the cuboid is 2 into length times breadth, that's 15 multiplied by 8, plus length times height, that's 15 multiplied by 13, plus the breadth multiplied by the height, that's 8 multiplied by 13. So in view of this, we can just simplify this and we'll have the answer of the total surface area. So this will be 2 into 120. 15 multiplied by 13 will be 995, and 8 multiplied by 13 will be 104. So this will be 2 multiplied by 419, and this will be 838 centimeter squared. 838 centimeter squared is equivalent to option B. So we see we evaluated the height. From the height, we're able to get the total surface area, understanding the formula thereby. Now let's proceed on, and we have Wassce 2024 objective question 27. The question says the number 1621 was subtracted from 6244 in base x. If the result was 4327, we should find x. Okay, this will go back to beginning where we learned about addition and subtraction in a particular base, where the results must be not be greater than the base value. So we have 6244, and then the value of 1621 was subtracted from it, and the result was 4323. The question is, what is the base x at which this was being done? So let's move further and let's look at how this was arrived at. 4 minus 1 is equals to 3. So we have this to be understood vividly. 4 minus 2 is equals to 2. So this was arrived easily irrespective of the base. So definitely the base is greater than 3 and is also greater than 2. Now let's move on. When we now get to this point, we have 2 minus 6, which is not possible. So then we move to 6. We have to ask for 1 from 6. So this 6 now is reduced to 5. Okay. When we move 1, there is a transference down to 2. That transference is the value of the base x. Okay. Such that this new value will be x plus 2. So x plus 2 minus 6 is equals to 3. Let's write it. X plus 2 minus 6 is equals to 3. And if you look at the last relation, 5 minus 1 is equals to 4, which is easily gotten. So all we just have to deal with now is the value of the base plus 2, okay, minus 6 is equals to 3. So with that, we can evaluate the value of the base x. So simplifying further, we have that x plus 2 minus 6 is equals to 3. And this will give us x minus 4 is equals to 3. So x is equals to 3 plus 4. Let's write the 4 well. And this x will be equals to 7. So we are dealing with base 7, which is a. So when 7 adds up to 2, 7 plus 2, we will have 9. And when 3 is subtracted from 9, we will have 3. Sorry, when 6 is subtracted from 9, we will have 3. So now we have that the base x is equals to 7, equivalent to option A. Wassce 2024 objective question 28. We are asked to factorize completely 27x squared minus 48y squared. 27x squared minus 48y squared. Now if we look closely to this, it looks like difference of 2 squared, where we have a squared minus b squared, okay, minus b squared is equals to a plus b into a minus b. So with that done, let's bring this to the format of difference of 2 squared. Now if you notice now, 27 is not a perfect square, neither is 48 a perfect square. So what we now have to do now is to simplify such that we will have perfect squares. 27x squared minus 48y squared, it will factorize completely by 3. This will result into 9x squared minus 16y squared. So with that done now, we can now move on further, because 9 will going to give us 3 squared x squared, and 16 is 4 squared y squared. And if we bring them together according to the law of indices, we'll have 3x squared minus 4y squared. Now all we just have to do to factorize completely is to apply the difference of 2 squared formula, and which is what we have here. Bringing it together, a squared minus b squared is equals to a plus b multiplied by a minus b. So this is a and this is b. So let's write it again. A squared minus b squared is equals to a plus b multiplied by a minus b. So in view of that, let's simply factorize completely. So factorizing completely, we have this to be 3 into a plus b, that's 3x plus 4y, into a minus b, and that is 3x minus 4y. So if you write it in plain terms, we'll have 3 into 3x plus 4y into 3x minus 4y, and this is equivalent to, let's write this, minus 4y. This is equivalent to option C, where we have 27x squared minus 48y squared. Applying difference of 2 squareds to give 3 into 3x plus 4y into 3x minus 4y. WAEC 2024 objective question 29. Now we are asked to find the value of x in these inequalities. So we have x minus 3 divided by 4 plus x plus 1 divided by 8 is greater than or equals to 2. So all we just have to do is to solve this inequality, and to do that we have to find the LCM of the left hand side. The LCM here is simply 8, and the numerator, this will result into 2 into x minus 3, and this will result into x plus 1, and still is greater than or equals to 2. So we can simplify the numerator now, or we cross multiply first. So let's cross multiply. If we cross multiply, we'll have 2 into x minus 3 plus x plus 1 to be greater than or equals to 2 multiplied by 8. So with that, we can simplify both sides by opening the bracket. So this will result into 2x minus 6 plus x plus 1 is greater than or equals to 16. So what are the values of x now? If you look here now, 2x plus x, this will give us 3x. Similarly, minus 6 plus 1, it will give us minus 5. And it is greater than or equals to 16. So therefore, we can evaluate that 3x when we add 5 to both sides, or move this minus 5 to the right hand side. So this will be 16 plus 5. So we have 3x is greater than or equals to 21. So we can divide both sides now by 3. 21. So let's divide both sides by 3, divided by 3, and divided by 3. So therefore x now, it will be greater than or equals to 7. And that will be the solution to the inequality, which equates to option C. Now we have WAEC 2024 objective question 30. Now we have this diagram. The question says, in the diagram, angle SQR, that means angle, this is 52 degrees, and similarly angle PRT, okay, that's angle PRT, is equals to 16 degrees, which we'll have here. And we are asked to find the value of the marked angle Y. We are looking for Y. So let's look closely at this diagram and see how we can evaluate Y. So with this now, we can see that the quadrilateral PQST, okay, is a cyclic quadrilateral. And in a cyclic quadrilateral, the opposite angles are supplementary. That means the opposite angle of a cyclic quadrilateral are equals to 180 degrees. So let's make that analysis here. So if we have a circle and we have a quadrilateral right inside of it with angles A, B, C, and D, we can say that the opposite angles of the cyclic quadrilateral are 180 degrees. So we are saying A plus C, their opposites, is equals to 180 degrees, and B plus D is equals to 180 degrees. Cyclic quadrilateral. Now, the opposite angle to Y in this case is equals to this angle. Let's call it angle P, or rather angle A. To get A, we will need to evaluate angle B, because A and B are angles on the straight line, which is equals to 180 degrees. So we can write it here, A plus B is equals to 180 degrees. And to get B, we have to use to get B, we have to use the sum of angles in a triangle. This is the triangle. Let's use another ink. Triangle QRS. So let's begin by evaluating angle B. So we will evaluate angle B from triangle QRS. That the sum of angles in the triangle is equals to 180 degrees. So we have B plus 52 degrees plus 16 degrees is equals to 180 degrees. And what are we applying here? The sum of angles in a triangle is 180 degrees. So with that done, we can now evaluate angle P. So we are saying that B, this will be B plus 68 degrees. B plus 68 degrees is equals to 180 degrees. So with that, B will be equals to 180 degrees minus 68 degrees, which will be 102 degrees. So moving on, we will now proceed further and evaluate the angle on this line. So we have A, okay, and we also have B, and A plus B is equals to 180 degrees. So let's call this A plus B is equals to 180 degrees. And what are we applying? The principle we are applying is that the sum of angles on a straight line is 180 degrees. So with that done, we can now evaluate our angle A. So therefore A plus 112 degrees is equals to 180 degrees. So when we make our calculation, A is 180 degrees minus 112, which is equals to 68 degrees. So let's come here now and label. We have A to be equals to 68 degrees and B to be equals to 112 degrees. Now, what we now want to do now is to evaluate Y. And from cyclic quadrilateral, we understand that the opposite angles of the cyclic quadrilateral is equals to 180 degrees. That means it's supplementary. So with respect to that, we can say that Y plus A is equals to 180 degrees. And the reason is that opposite angles of a cyclic quadrilateral is supplementary. That means is 180 degrees. Cyclic quad is 180 degrees. So our Y, which is the angle we are looking for, is equals to, so we are saying Y is equals to 180 degrees minus A. Our A is 68 degrees, so that's 180 degrees minus 68 degrees. Let's rewrite this. 68 degrees, and this means that our Y is equals to 112 degrees, equivalent to option C. So we can see now that we started from angles in the triangle to angles on the line to opposite angles of a cyclic quadrilateral.